AP Chemistry. This is part 5 of the Thanksgiving midterm assignment answers video, and we're going to continue with problem 20A. Alright, so calculate the molarity of 0.492 grams of magnesium nitrate in 250 milliliters of solution. Okay, so it's 0.492 grams. I'm going to start way over here. Okay, so we need to get from grams of magnesium nitrate to moles. That's a molar mass conversion. And we need to get from milliliters to liters, so that's a pretty standard conversion. So it's going to be 2 conversions. Let's go ahead and do that. Okay, so we need to know the molar mass of magnesium nitrate. Alright, so I'll come down here to calculate that. So magnesium, you have one of those. And it is 24.31. You have 2 nitrogens at 14.01. And you have 2 times 3, it's 6 oxygens. You have 3 oxygens, and then you have 2 of those, so it's 6 oxygens. Okay. So that is going to be 24.31 plus 28.02 plus 6 times 16 is 96, and that gives us 148.33 grams per mole for magnesium nitrate. Okay, so we're working on the top. I should have stated that. We're going to work on the top first using the molar mass. So which goes on top, which goes on bottom in this first box. You need grams to cancel out, so grams has to go on the bottom. Grams cancels with grams, so we have moles of magnesium nitrate on the top. Okay, so now we take care of the bottom. It's milliliters to liters. That's pretty standard. And it's of solution. Milliliter solution, so you have liters on the bottom of solution, moles of magnesium nitrate on the top, so everything is set up properly. So it's 0.492 times 1000 divided by 250 divided by 148.33, and that gives us 0.13. 0.013. And that's molarity, so the final answer should be written as this. Capital M, molarity. Okay, so you go ahead and do 20B, and we're on to our last problem. It has 4 parts to it. So assume you dissolve 3.16 grams of malic acid, there it is the formula, in 650 grams of water. Calculate. And you might not necessarily want to calculate these in the order that they give them, but we'll see how it works. So we have grams of solute and we have grams of water. Okay. Okay, so the first thing I'm going to do is I'm going to come down to the bottom of the page. I have a lot of space here. I'm going to figure out how many moles of each of these we have. So we have, and I'm going to refer to malic acid rather than that formula as malic. Okay, and we need to know the molar mass. So you want to learn to get to where you can do these fairly quickly in your head. Okay, and I was off by a little. It's actually 134.1. Grams cancels with grams. And the number of moles we get is 0.24 moles of malic acid. Alright. Okay, let's do the same with water. Okay, we have 650 grams of water. And we know the molar mass. Okay, and that's going to give us 650 divided by 18.02, and that's going to give us 36.1 moles. What we also know is 650 grams equals 0.65 kilograms, and if it's pure water, this is for water only, then that's going to equal 0.65 liters of water. So we know how many liters of water we have. Okay, we're going to need, since this is a 4-part problem, we're going to need this information at various points along the way. So molarity, what is molarity? Okay, so we need moles of malic acid. We just figured that out down here. It's 0.24 over liters of solution. So this problem gives you liters, it gives you grams of water, which we converted down here into liters of water. But liters of water is not liters of solution, it's liters of solvent. We don't have any way to know how many liters, what the volume is of this solution with this added in. We would need a density of a malic acid solution, and we would need to know how many grams per liter that is. So our only alternative is either just to not solve the problem or to say that 3.16 is less than 1% of 650. It's a very small amount. So we can say that the liters of water is approximately equal to the liters of solution. Now, yeah, that's a little bit of a fudge to do that, but we're going to go ahead and do it, otherwise we just can't solve the problem. Okay, so what we're going to do is we're going to go ahead and say it's 0.24 moles of malic acid over 0.65 liters of water, but we're going to say that approximately equals the liters of solution. So therefore we're going to just do a division here and say that that's our answer. It's off by a slight amount, but not enough for us to concern ourselves with. Now, how do you know when you can make that approximation? There's no real rule for it, but it's just simply we're going to say that we know this is very small compared to this, and therefore we're going to go ahead and do it. Otherwise, we just can't do the problem. Okay, how about molality? Now, this one we can do. We have kilograms of water right there. We know that. We figured that one out. So that one is going to be moles. Okay, and you don't have to make any approximation here. This is exactly it. So it's 0.37 molality it's looking for. Moles of malic acid over kilograms of water, so that's small m. And this up here, although it's a little bit off, we're going to say it's molar as well. Okay? All right. Mole fraction. Well, didn't leave myself a lot of space for that, so I'm going to come up here and do this one, because I don't need to use that space. You do, so you might want to do this on line paper if you're running out of space. Okay, so what is it? It's moles of malic acid. Okay, and I'm just going to put the numbers in. So moles of malic acid is 0.24. Moles of H2O is 36.1. So, okay, and when we add all that together, be sure this doesn't get confused there. So it's going to be, and we get this 0.0066 to two significant figures right there. Okay, and that's the answer to this one for mole fraction. All right, and now we got one more on the next page. And that's the mass percent of the acid in solution. So now we have to come back to almost the same thing with mole fraction, except we do it with grams. So we have 3.6 grams of malic acid and 650 grams of water. So it's simply going to be the grams of this over the grams of the two of them combined, and then you multiply by 100%. This is a percentage. Okay, so we'll go ahead and do that. 3.16 divided by parenthesis 3.16 plus 650 close parenthesis equals, and then we multiply that by 100 and we get 0.48%. So what we said earlier in the first part with the approximation is that the malic acid is a very small fraction of the entire solution, or percentage of the entire solution. It's only about 0.5%. So making that approximation in the first part for molarity was reasonable, and the error won't be that great. You probably have to go to the third significant figure to find any difference. Okay, that's it for me. Now you go on and do all the B problems. I will post the answers to these B problems, just the answer, not the entire worked out solution the way I did. You do those on your own. The important thing is that you know how to do these. You practice these. If there's one that you find tough, I would do it 2 or 3 or 4 times until it just you at least have the answer memorized, and then from that, I mean the solution, the entire solution memorized in your head, and then from that the understanding will come later. Okay, so that takes care of it for the Thanksgiving midterm assignment, and good luck, and work hard on it.